How to deepen knowledge of energy engineers from companies? The European project EUREM Next offers efficient know-how and tools. Interactive e-learning courses, workshops, networking meetings, and international conferences collect new ideas for improving energy savings and renewable energy integration in companies. One of the main interests of the program EUREM Next is e-mobility. Therefore, e-mobility and also so-called microgrids will be our today's topics. A guest of our interview is Mr. Clemens Wiegehaupt from the company Siemens AG. Welcome.
Thank you very much. Nice to hear you.
You are working in the department microgrids within Siemens AG, which sounds very interesting. So, with which specific topics are you dealing in your job?
So thank you for that question. I'm working now over 10 years in that field of microgrids and renewable integration. And I can tell it's a really, really interesting topic I burn for. And which also gets more and more relevant to today, because the biggest challenge of our time is to shift towards a sustainable way of living on that planet. And I'm passionate about innovative technology that enables the fundament of sustainability, providing energy control solutions to tackle that challenges of that new required energy landscape. And this means that we will have more than, for example, two different generation sources in one system. And as more and more of this hopefully renewable energy sources, energy storage devices, and decentral generation is integrated into that grid, we are moving away from a big thing powered by a big central plant to a grid that develops in something like smaller cells. So you can think about an orchestra consisting of different musicians, and you will need someone who conducts that orchestra. And so that's exactly what we do. We, or my department and my daily business, is to care about industrial systems, mining, campuses, critical infrastructure, but also larger buildings, as in my project thesis. And we supply smart energy solutions that enables to minimize, for example, the environmental impact and maximize the economical benefits. And the EUREM training, so IHK training, that training course gave me the right understanding for the requirements of the different markets, of the different technologies, and what to tackle and what's the pain of that customers. And from my point of view, it was, if not the best training course I ever visited. And it gave me a really wide view on the whole portfolio in industry.
Actually, how did you get involved into EUREM course?
Yeah, that's a funny story, more or less. My boss asked me if we are interested in having some trainings and where to develop. And as I told, we have to care about a really broad portfolio of technologies and whatever. And I searched for different training courses on Google. And one of that results was that training course in IHK. Luckily, because really it is dealing with different technologies. You have the possibility to talk to people coming from industries. So it's not more or less a teacher in brackets, that who studied something like that. It's really people whose daily business is the topics they talk about. So if it's heating, air conditioning, CHPs, photovoltaics, really a broad portfolio of topics. And luckily I found that course. I really recommend to have a look at that course. And as I told, it is one, if not the best training I ever visited. Thank you.
But let's go back to our today's topic, which is microgrids. The electrical world and environment is changing. Political goals are aiming on to be CO2 neutral till 2040. So how can microgrid support the political goal to be CO2 neutral till 2040?
Yes, from our point of view, so generation is not longer the domain of the big generation companies. So if I look out of the window, a lot of blue and black tiles on the roofs. So more and more private investors can now invest in that technology. So generation, how to fulfill their energy demand by themselves and see a return of invest. And that means microgrids is the core of the investment in security and also contributing in the CO2 commitments of the government. So Siemens or we as microgrids make a valuable contribution to achieve the goals of being CO2 neutral. So based on our products or our solutions we create with different products. So for control and integration of renewable energy generation systems, we can create, so to say, the maestro in the middle of an orchestra. So orchestra of renewables, and these solutions allow existing as well as new systems to be made climate neutral by expanding them with renewable energy generation systems and storage systems. And it is important not to forget that the integration of that renewables, especially in my region of Germany, southern part of Bavaria, is often requiring an extension of the electrical grid, which can often only be achieved with a great deal of effort. So also part of my project thesis, probably we came to that later. Especially if we talk about one part of that CO2 neutrality, it's e-cars, integration of e-car infrastructure. You will need some intelligent controls to avoid that grid expansion and minimize costs, because in the end, unluckily, it's mostly all about costs. And if there is no way, we will do one, probably with our products, with our control, but mainly and mostly, and that's the most important part, with intelligent concepts and smart concepts, like in my project thesis. Hopefully I can name it like intelligent concept.
According to the current development, more and more infrastructure for e-mobility has to be integrated into the electrical grid. Which challenges, according to you, have to be tackled to bring this to success?
Yes, that was also one part of that project thesis, and we saw that old grid equipment or the old grid infrastructure is often too weak to be that it's possible to integrate more loads. So especially e-car charging. If you think about a Tesla charger with over 100 kilowatt, if you think about a home for 4 people, it's around 5 kilowatt. Quick charger, 100 kilowatt. So I think the main challenges of e-car integration is physics and comfort, or vice versa, because comfort is bound on charging times. So everyone wants to have an e-car that more or less is like a normal car. You drive to a gas station, you put you fill up your tank within 2 minutes and you drive further. So comfort is bound to charging times, and these times are bound on physics, so electrical power. As I told, for example, some quick chargers over 100 kilowatt. And so we have to find ways, or we need to find ways to integrate charging equipment in existing, often older electrical grids without exceeding the limits of this environment. So pure physics. And the customer's needs is a very structured and efficient process, analysis of the current situation, finding the best fitting solution and strategy, economical and technical, and implementing a solution that allows to use an existing environment to integrate that e-car infrastructure, or to analyze what is the economical best plan for this extension. So this is a lot of challenges, but there is a real realistic chance. The tools are there, the knowledge is there, the experience is there. So let's tackle these challenges. And this is an investment for the future. And we, Siemens, can meet and grow with the customer needs as they expand. So really, there is a chance. And I think there are a lot of possibilities. And if we put some intelligence in, it is really realistic, to meet the goals of, for example, 2040.
One of these possibilities is also mentioned in your project thesis. So let's introduce it a little bit more. Your project thesis was dealing with how to integrate e-mobility in existing environment, avoiding the extinction of the grid. So do you think this can be applied in other environments too?
Absolutely. I'm absolutely sure that this can be applied for other regions, for other customers also, because the concept was not 100% bound on our products. It was not bound or based on a special environment or something like that. It's more or less a typical, we name it brownfield environment. So something existing and something with limitations. For example, with the transformers that are limited in power, and also bound or based on some typical requirements a customer has. For example, that demand charges, to keep peaks of load as low as possible, because at peaks, the demand charges are often the reason for high energy bills. So the results of the thesis, that is not made for specially one Johannesbad, one customer. It is based on, yes, but it can be applied on others also. The results of this thesis was more than positive, and our solution with an intelligent control is enabling the integration of a larger number of e-car charging poles using an existing older transformer. So also using or based on the limitations which are there. And furthermore, in this thesis, it would also be the system would also be extendable with an energy storage device. For example, in future, there was a second step, a second phase of that project to integrate a battery energy storage system that allows that also to make the economic benefit even larger, even bigger. So the concept proved that cost reduction potentials of over 60,000 euros per year with a payback time, in the first step only based on control of half a year are not unrealistic. And more than that, not even economical aspects are pushed into the positive side. Also CO2 savings of more than 100 tons per year can be achieved. So all in all, we can see that the new challenges are a chance, to get more economical and more ecological. If we use what we have with some smart ideas and probably or hopefully with our products, we can really change the electrical landscape into a greener one. And smart ideas are generated by knowledge, and it was my observation that the URAM training, the IHK training course, is one part of getting that interdisciplinary knowledge and in a very efficient way. And this is, for me, this was key for that thesis to get that knowledge about different technologies and where to look at, what's the pain and so on. It was really the key to be able to generate or to create a thesis like I did for Johannesbad.
If we speak about this specific project for Johannesbad, is this proposed project still in a form of theory, or is it already in some stage of realization?
It is in some stage of realization, but unluckily the whole world was hit by that pandemic, by Corona, and it is in some stage of realization, but I do hope that the delivery change, economics, and all of that things, our normal life or our life gets back and will get normal the next weeks. So I hope that I get contacted the next weeks, that the project is more or less in the next stage of realization.
Clemens Wegerhaupt from the company Siemens AG says, thank you very much for being a guest of today's interview.
Thank you very much. Thank you for that chance, for that interview. And let's use the chances that are out there. Let's use the products, the smart ideas. I think, we can change the world. It's one sentence, but it's really my hope and really my motivation. Thank you.
I hope too. Thank you very much. And in the next podcast, we will return to the energy audit support tool, and we will introduce what experience one specific company has with its use in practice.